Hello. In this introductory module, we will talk about cooling systems. First, we will recall where the cooling systems are used. Then, we will briefly talk about different methods of cooling and their advantages and disadvantages. And finally, we will focus on what we will learn in Seneca BES222 Applied Air Conditioning and Refrigeration. Ready? Let's begin. Why do we use cooling systems? Cooling systems are required to keep our buildings comfortable. Remember that we have learned that one of the main goals of building systems is providing occupants with comfortable and desirable conditions. Where and how do you think cooling systems are applied? We have learned from our previous courses that buildings based on their size and functions can be categorized in either residential, commercial, large, and multipurpose. In residential buildings, cooling systems can appear as central air conditioning systems, window units, or as simple as a fridge in your kitchen. In commercial or larger buildings, depending on the building functions, cooling systems are used to take the heat generated inside of buildings away. Whether it is a large office tower, an assembly building like an auditorium, a hockey arena, or a supermarket, cooling systems are there to provide desirable conditions. Even water fountains that give you cold water in a hot summer day use a cooling system. Cooling systems are also widely used in the automotive and transportation industry. Your car air conditioning system is indeed a small cooling system that makes driving in a hot summer day much more desirable. The food production and distribution industry is heavily dependent on a network of refrigerated trucks, and that's how you can enjoy a fresh glass of milk days after it is produced at the source, miles away from your home. In this course, we will learn that at the heart of most cooling systems is the mechanical refrigeration cycle. Let's get familiar with basic mechanical refrigeration cycle's 4 components. We will talk about these components in future chapters. These components are evaporator, compressor, condenser, and the expansion valve or metering device. In this course, and many HVAC resources, the cooling system diagram is shown in a way that the 4 main components are visible and in the correct order. The simplest way to provide cooling in a building is ventilation, either by natural means or mechanical devices such as fans. This method of cooling has a lot of limitations. For example, it will be effective if the outside air is cooler than the inside. But what if, as in most summer days, the outside air is hot? One solution could be installing window-mounted air conditioning machines. That can be effective if we were cooling a small space such as a room. But even for a small house, you probably need more than one of these machines. The window-mounted air conditioning systems are usually not that efficient. One of their common problems is that these machines are not installed in a perfect sealed manner, and there is usually a lot of unwanted air infiltration or exfiltration that significantly reduces efficiency. Moreover, especially in taller buildings, there is always the danger of one of these machines falling, which is a real hazard. Small buildings and houses often use a central air conditioning system. These systems, even though effective for a small building, lose their efficiency when used in larger buildings. If we want to use a central air conditioning system for a larger building, we must pay attention to the fact that it takes a large amount of power to move air to long distances. Subsequently, the airflow will not be evenly distributed. Rooms at the end of the line will receive less air. Also, the air that reaches the end will be warmer because it picks up heat. In this course we will learn that cooling can be provided in large buildings by cooled or chilled water. In fact, the cooling systems that use water as the mean of heat transfer, or hydronic cooling systems, are our main focus in this course. For now, keep in mind that water is easier to pump, easier to control, and has high heat capacity comparing to air. In the coming chapters, we will briefly talk about the rooftop units, as simple hydronic systems, and how they can produce cool water that is sent to the occupant's space to provide cooling. In this diagram, you can see how the water is cooled in the rooftop unit, then is sent to the occupant's space to pick up heat. When the water picks up heat, it gets warmer, and that is why it is shown in this diagram by red. Our main discussion in this course is about full-size hydronic cooling systems. Naturally, we will first talk about the chiller, as the main component of any hydronic cooling system. Then we will learn about other components such as cooling towers, pumps, different water loops, controls, and maintenance of the cooling systems. By the end of the course, students will have a better understanding of the journey that heat takes from inside of the building to when it is finally released outside. We will also discuss alternative, innovative, and sustainable methods of cooling such as district cooling and heat pumps.